Okay, good afternoon to one and all. So, in the previous lecture of electrical machine first, we have discussed regarding speed control technique of DC shunt motor. So, there are three methods to control the speed of DC shunt motor. In this method, there are first one is nothing but by controlling the flux of the top field winding. Second one method is nothing but by controlling the armature voltage, that means voltage across armature. And the third one method is nothing but we want to control the supply voltage, that means by applying this third technique or the controlling supply voltage, we are able to control the speed of DC shunt motor. Okay, right now, so these three technique I have already tell, and in that three technique I have we have already discussed regarding first two technique, that is flux control of DC shunt motor, flux control of DC shunt motor, that is we can call it as a field control technique. And second one technique we have already discussed, this is nothing but the armature control technique, that means by controlling the armature voltage we are able to control the speed of DC shunt motor. Okay, now today we will discuss about the next one technique, is that next one technique, it is nothing but controlling the supply voltage, so we can call it as a voltage control technique. Controlling the supply voltage, it is nothing but the voltage control technique. So this technique we will discuss for today. Now see, do you know that there are supply, it can be provided to the top DC shunt motor. So suppose this supplied voltage or it may be applied voltage, if we change this value of voltage, then the speed of DC shunt motor it can be changed, right? No, जर supply voltage जे आहे ते voltage change केलं, then there is a speed of DC shunt motor, it will also change. DC shunt motor चं speed काय होईल, change होईल, right? No, बरोबर ना? If I change the supply voltage according to equation, that is equation n is directly proportional to n, it is directly proportional to EB divided by phi is nothing but V minus IA into RA, V minus IA RA divided by phi, V minus IA RA divided by phi. That means by controlling that technique, by using that technique or by using this technique, we are able to control the speed of DC shunt motor. DC shunt motorचं speed काय करू शकतो आपण, control करू शकतो. Okay, so that is we have discussed that technique. It is nothing but n, it is directly proportional to V minus IARA divided by phi. We have discussed regarding by controlling the flux, we have discussed regarding by controlling the armature voltage. So armature voltage is nothing but EB, it can be controlled by inserting some of the resistance in series with that of armature circuit. And next one is nothing but by controlling the supply voltage or by changing the supply voltage, we are able to control the speed of DC shunt motor, right? DC shunt motor चं speed आपण supply voltage control करून change करू शकतो. Now see, in this method, the voltage source supplying the field current is different from that which supplies the armature. See, in that condition, the field it can be kept constant. That means we are using one separate source or one separately another one source to excite the field winding. म्हणजे field winding ला excite करण्यासाठी आपण एक separate source use करतोय. Suppose this is the shunt motor, this one is the armature, and this one is the supply voltage. Instead of giving a supply voltage common for both armature and field winding, we are using one of the extra source or separate source to excite the field winding. Field winding ला excite करण्यासाठी आपण काय करतो, separately एक source use करतो. That means if the supply voltage change, there is a no effect on that of flux produced by field winding. That means phi remains constant. So we are maintaining phi constant we are changing the supply voltage only. So this speed equation becomes, if the flux phi is equals to constant, ज्यावेळेस flux phi हे constant असतील, when the flux phi it will be constant, En is directly proportional to V minus IARA. Okay, if IARA is made constant, that means there is no resistance, it can be inserted in series with field winding. We are changing only voltage applied to that of armature. Armature ला apply केलेलं voltage काय करतोय आपण, change करतोय. So if voltage applied to that of armature it will be changed, then the speed of DC shunt motor it will be changes, or the speed of DC shunt motor it will be varies. Okay, now see, this method avoids the disadvantages of poor speed regulation. As we know that in case of armature control म्हणजे आपण जी काही सेकंड मेथड कन्सिडर केले. So in case of armature control technique of speed control, in that technique we are just inserting one of the resistance in series with that of armature circuit, and this resistance it will carry a maximum current, or it may be a full load current, rated current it will carry. If the current carried by that field winding armature it is nothing but rated current, then there is a loss it will be occur, that is copper loss it will be occur is more. Due to this more heat dissipation or the more loss, the speed regulation it will be poor. We have discussed regarding disadvantages of armature control technique. Armature control methods आपण disadvantages पाठीमागच्या लेक्चर मध्ये बघितले आहे. So in that the speed regulation it will be poor, and the efficiency it is also poor. त्याची efficiency पण काय होती, poor होती. Okay, so see this if we use the supply voltage control technique, or if we use the controlling the speed by using or by changing the supply voltage, it will avoid the disadvantages, or it may be it will recover the disadvantages of previous system. हा जो काही disadvantages आहे, that means poor speed regulation and the low efficiency in case of armature control technique. So this can be avoided. Okay, however this technique it is quite expensive. ही जी काही technique आहे, it is an expensive technique. Therefore the voltage control method of speed control it is employed for large size motor where efficiency is great importance. So this technique it is an expensive आहे technique, or cost requirement for this technique it is nothing but more. So this technique of speed control, that is multiple voltage control. So this voltage control technique it is used where for large size motor is there, or large size machine is there, and having an efficiency it is a greater importance. The efficiency is a greater importance आहे, at that condition we are using. Okay, so this is related to this voltage control technique, some of the advantages, disadvantages. Now see, again in case of voltage control technique or the voltage control method, this can be divided into main two types of speed control. Okay, बघा ही जी काय voltage control technique method आहे, it can be divided into, or again it can be differentiated into two part, or it is classified into two method. First one method is nothing but multiple voltage control, and the second one method it is nothing but a Ward-Leonard system. First one method काय आहे, method number first it is nothing but multiple voltage control, and second one technique it is nothing but Ward-Leonard system. Ward-Leonard system of speed control. Now see, in this method, the multiple voltage control method, the shunt field of the motor it is connected permanently across one fixed voltage. So field winding ji ahe, it is connected to one fixed or permanent voltage source, and the armature, it can be connected across several different voltage by using one of the suitable switchgear. Okay, so by using one of the suitable switchgear equipment, that means suppose we are using a variable transformer like Varac, or we can call it as a auto transformer. So by using such types of equipment, we are giving a supply voltage to that of motor gradually, or we are changing the supply voltage of that of motor, but by keeping the field circuit remains constant. That means field circuit, it is connected to a permanently fixed voltage source. एका fixed voltage source ला आपण काय करतोय, field winding connect करतोय. We are applying a change in voltage only for armature. Okay, so in this way the voltage applied across the armature, it can be changed. So see, suppose the field winding, it can be connected by one of the fixed voltage source. एका fixed voltage source ला field winding काय केले, connect केले, and the armature of the machine, or it may be armature of the motor, motorचं जे काय armature आहे, where the variable voltage, it can be applied. याला जर मी काय केलं, variable voltage apply केलं. Okay, variable voltage applied. See, the flux produced by due to that fixed voltage source, flux phi is constant, and the equation becomes En is equals to, or En is directly proportional to V minus IaRa. Again, we are not inserting some of the resistance in series with that. We are changing the value of voltage only. That is applied voltage. If initially the applied voltage, it is nothing but 100 volt, then the speed of the motor somewhat get, it is nothing but 1000 revolution per minute. If I change this voltage, that means suppose I will apply the voltage, it is nothing but 200 volt. Because of direct relation, V increases, the speed of the motor, it will be increases. So as the V increases, or it may be supply voltage, it will be increases, the speed of DC shunt motor, it will be increases. So at 200 volt, the speed, it will be getting near about 1500 revolution per. So like that, by changing the supply voltage, or by changing the applied voltage across the armature, so the speed, it can be increases. Okay. In this way, the voltage applied across the armature, it can be changed, and the speed will be approximately proportional to voltage applied across that. जे voltage आपण apply करतोय त्याच्या approximately proportional to the top speed असेल. So suppose voltage increases, the speed of the machine, it will also increases. Okay, now the intermediate speed can be obtained by means of DC shunt field regulator. Okay, so if we use the shunt field regulator, then we are achieve a intermediate speed. Intermediate speed is nothing but in between that two technique speed, like a intermediate speed. Okay, so this is one technique like multiple voltage control technique. Now this is not mostly used, this is rarely used. Then next one type of voltage control technique, or next one type of speed control technique, it is very important and it is interesting. So see, this is nothing but the Ward-Leonard system, speed control by using a Ward-Leonard system. Speed control by using a Ward-Leonard system. Now see, in the Ward-Leonard system, the adjustable voltage for armature, it is obtained by adjustable voltage. It can be obtained from an adjustable voltage generator. See, in this technique, that is Ward-Leonard system technique, here it is figure. Now see, in the Ward-Leonard system, there are two same identical machine are used. Okay, so two machines are directly coupled to each other, and whose speed control we want to do. So this motor, it is connected to output of a generator. Now see, The set for that, for Ward-Leonard system, Ward-Leonard system, it is nothing but here we required two identical machine, दोन identical machine पाहिजे. One of machine, it can be run as a motor, one of the machine it can be run as a generator, and another one motor, it is nothing but whose speed we want to control. ज्या मोटरचं मला स्पीड कंट्रोल करायचं आहे, or which motor we want to control the speed. This motor, it is nothing but M1 motor, and I required another two machines, that is similar machine I required to use this technique, that is Ward-Leonard system. बघा लक्षात घ्या, if I want to use the Ward-Leonard system of speed control, I require see I required two identical machine, another two identical machine in the combination of the motor whose speed we want to control. ज्या मोटरचं स्पीड कंट्रोल करायचं आहे ती मोटर plus another two identical machine it will be required. So from that another two identical machine, one machine it can be run as a motor, one machine it can be run as a generator. त्याच्यामधली एक मशीन मोटर म्हणून रन होईल, एक मशीन जनरेटर म्हणून. Now see the field winding of both the motor, that means M1 it is nothing but one motor whose speed it can be we want to change. एक मोटर आहे त्याचं स्पीड मला काय करायचं, चेंज करायचे, म्हणजे त्या मोटरला स्पीड कंट्रोल टेक्निक अप्लाय करायचं. सपोज आय वॉन्ट टू चेंज द स्पीड ऑफ द मोटर, इट इज नथिंग बट फ्रॉम 100 revolution per minute to I want to achieve 1000 revolution per minute, right? No, so see at that situation, if I use the Ward-Leonard system, so Ward-Leonard system it is applicable where the large size of machine it can be present. जिथं large size च्या machine आहेत, for that large size of machine the setup it can be used like motor generator set, or we can call it as a MG set. It will require to control the speed of DC shunt motor or the speed of motor by using Ward-Leonard system. Ward-Leonard system मध्ये आपल्याला जर स्पीड कंट्रोल करायचं असेल किंवा एखाद्या मशीनचं स्पीड कंट्रोल करायचं आहे by using a Ward-Leonard system, then we required one MG set, extra MG set पाहिजे. Now see this method it is used for the application in case of rolling mill, in case of paper mill. Okay, paper mill application असेल, rolling mill application असेल, or it may be a textile industry is there, or it may be a steel industry is there. So in that there are big size of machine is there and big size of roller it can be attached to the top machine is there. त्या मशीनला big size चे roller काय केलेले असतात, attach केलेले असतात, or motor it can be used to drive this roller. It is nothing but having a big size. Okay, now if we use the Ward-Leonard system, if we use the Ward-Leonard system, we are able to carry the we are able to control the speed of that machine having a range, it is nothing but near about 1:10 or 10:1. Okay, in both direction. All of you understood my concept, what I am telling? See, Ward-Leonard system it can be used where the large size of machine is there. So generally application for that is nothing but in case of rolling mill, in case of paper industry, or it may be in case of textile industry, where the machine it will runs a roller, big size of roller जो असतो तो machine काय करते, run कर. At that situation, if I want to control the speed of that motor, if I want to control the speed of the motor having in the range of 1:10 or it may be 10:1, म्हणजे suppose rated speed of the motor it is nothing but 1000 revolution per minute, or somewhat consider rated speed of the motor it is nothing but 5000 revolution per minute, right? See, the rated speed of the motor it is nothing but 5000 revolution per minute, if I want to control the speed of that motor from this motor, it can be, I want to achieve the speed near about 1000 revolution per minute, or it may be I will achieve the 5000 revolution per minute. Suppose initially motor it can be run at 100 revolution per minute. I will achieve the speed of that motor, or I will get the speed of that motor up to 1000 revolution per minute. म्हणजे 10 एम्पियरला रन होणारी मोटर आपण 1000 एम्पियरला रन करू शकतो, आणि 1000 एम्पियरला रन होणारी मोटर आपण 10 एम्पियरला रन करू शकतो. गेटिंग? लक्षात आलं? सो इट इज द मीनिंग ऑफ 1:10 and 10:1. Also, this speed it can be achieved in both direction. That means it is achieved in the forward direction also, and it can be achieved in the backward direction also. All of you understood this point? The speed it can be controlled by using a Ward-Leonard system having in the range of 1:10 and 10:1. That means 1 ampere ला 1 revolution per minute ला रन होणारी मोटर मी 10 revolution per minute ला रन करू शकतो, and 10 revolution ला रन होणारी मोटर I can achieve the speed up to suppose it may be a 1 revolution per minute. Okay, suppose the rating of the motor it is nothing but 1500 revolution per minute. So if the motor it can be running on 1500 revolution per minute, I want to achieve a multiple speed. Suppose this motor it can be run for 1000 revolution per minute. This motor it can be run for 750 revolution per minute. I am able to run this machine for 500 revolution per minute. I am able to run this machine for 250 revolution per minute. Also, I am able to run this machine for 125 revolution per minute. Okay. As possible as minimum speed it can be obtained. Also, as possible as maximum speed it can be obtained. Getting? Lakshat ala? Hello? How it works, I will show. Concept लक्षात आला का? कशासाठी यूज करतो आपण हे?
Yes, sir.
Okay. See, generally this system or this method it is used where the big size of machine is there. जिथं big size चा motor आहे आणि त्याचं speed मला as per my requirement, I want to control the speed of that motor having an wide range. Wide range मध्ये म्हणजे 1:10 or 10:1 range मध्ये मला काय करायचंय? कंट्रोल करायचं. Okay. So this machine it can be big because of cost requirement is also big. Cost requirement big आहे. Now control the speed of DC shunt motor, or we want to control the speed of that machine. We required one additional MG set. That means one motor generator set it can be required. Now see what it can be done. Suppose in that figure this M1 it is nothing but one motor whose speed we want to control. M1 ही एक अशी मोटर आहे की त्याचं स्पीड मला कंट्रोल करायचं. From 1:10 range or it may be 10:1 range. म्हणजे जी 1000 ला रन होते, in between that 1000 एम्पियर ला रन होणारी 1000 रिव्होल्यूशन पर मिनिट ला रन होणारी मोटर मला 750 रन RPM ला रन करायचे for some time. For sometimes I want to run this machine to 500 revolution per minute. For sometimes I want to run this machine for 250 revolution per minute. Again, after that 250 revolution per minute, I want to run this same machine to 1000 revolution per minute. That means 1000 एम्पियर 1000 revolution per minute ची मशीन 750 ला रन करायचे. 750 वरून 500, 500 वरून 250. Suppose 250 ला रन होणारी मोटर I want to achieve a speed of 1000 revolution per minute. So there is a wide speed varying range, wide speed requirement, or it may be wide speed variation. So see, consider the M1 is nothing but one type of motor whose speed we want to control by using a Ward-Leonard system. Ward-Leonard system चा यूज करून काय करायचंय? मला याचं स्पीड कंट्रोल करायचं. Now see, in that one of the additional MG set is there. So this motor and generator set it can be used. This one is the motor and this one is the generator. So this is the mg set. Here it can be directly coupled, motor and generator, it can be directly coupled to each other. ते दोन्ही काय केले, डायरेक्ट मेकॅनिकल कपलिंग केले. सपोज दिस वन इज द वन डीसी लाइन, ही जी काय आहे, it is nothing but one DC line or DC supply line. DC supply, it can be provided to that of field winding of the motor whose speed we want to control. Field winding of this motor, याच्या field winding ला connect केले. Also we are giving a supply, that is armature supply from the same line, and again the generator, it is having an field winding. So this field winding, it is also excited from this line. त्या लाइन पासून काय केले, एक्साइट केले. Now see, initially this motor it can be started. Okay, initially ही motor काय करतो मी, start करतो. Now see here, whose speed we want to control, the input applied to that of motor, it is nothing but it is the output of generator. Generator चे जे काय output आहे, it is applied as a input to that of motor whose speed we want to control. ज्या मशीनचं मला स्पीड कंट्रोल करायचं आहे. So for controlling the speed of that machine or the speed of that motor, I am using as a input is nothing but output of generator. Generator चे जे काय output आहे, ते मोटरचे input apply केलं. Now see, when I start this motor M2, ज्यावेळेस मोटर M2 स्टार्ट केली आहे, suppose the M2 motor, it will be running at somewhat constant speed. Suppose M2, it can be running on 1500 revolution per minute. At how much speed the generator it can be run? Generator कोणत्या स्पीड ने रन होईल? Same speed. Because generator and motor, it is directly coupled. So generator, it will also run on 1500 revolution per minute. Okay, generator पण त्याच्या same speed ने run होईल, because there is a direct coupling is there. Here the shunt field winding of the motor, it is constant, that is याच्यामध्ये produce होणारा flux constant आहे. So this motor, it is running on a constant speed because it is DC shunt motor. Instead of using DC shunt motor, we are able to use a induction motor also. In here, इथं आपण induction motor पण use करू शकतो. See, this is a constant speed motor, and this motor, it will be drives a generator. If the generator start rotating, what will happen? Generator rotate व्हायला start झाले, what will happen? What is the principle of generator? Working principle of generator? Field winding of generator, it is also excited. जनरेटरची फील्ड वाइंडिंग एक्साइट केली आहे. जनरेटरला ऍज अ इनपुट म्हणजे मेकॅनिकल इनपुट दिलेलं आहे. व्हॉट हॅपन इन केस ऑफ जनरेटर, वेदर इट विल बी जनरेट सम ऑफ द इलेक्ट्रिसिटी or not?
Yes.
Okay, that means the generator, it will generate some of the electricity, and this output of generator, it can be fed to that of motor whose speed we want to control. ज्या मशीनचं मला स्पीड कंट्रोल करायचंय, त्या मशीनच्या इनपुटला जनरेटरचं आउटपुट काय केलंय, प्रोव्हाइड केलंय. ओके, गेटिंग, लक्षात आलं कन्स्ट्रक्शन काय केलंय?
Yes, sir.
Okay, now see, this machine, it can be run as a constant speed. The constant speed na run hote, so speed of the generator, it is nothing but constant. Now see, what is the formula for induced EMF? Easy, it is equals to phi p n z divided by 60A, right? No, this A is constant, total number of conductor is constant, P is constant, so EG, it is directly proportional to phi into n. Easy, it is directly proportional to phi into n. That means generated EMF, it is depends upon flux and speed of generator. Again, the speed of generator, it is constant. Generator's speed constant है because motor, it is run on constant speed. Motor constant speed ने run होते, right? बराबर?
Yes, sir.
So easy, that is generated EMF, it is directly proportional to flux. Where it is flux? Flux is here. right? No, flux कुठं प्रोड्यूस होत आहेत? फील्ड वाइंडिंग. नाउ सी, in case of this field winding, if I change the flux produced by that field winding, if I increase the flux or it may be decrease the flux by using here the one field regulator is there. Okay, एक field regulator use केलेलं आहे. Field regulator, it is nothing but one variable resistor. By varying this value of resistor, I am changing the value of flux, and if the value of flux it will be changes, the induced EMF of the generator it will be changes. If the induced EMF of the generator it will be changes, this induced EMF or the voltage it is applied to the top motor whose speed we want to control. So due to this change in induced EMF, the speed of DC shunt motor it is also changes, right? No, speed काय होईल मोटरचा? चेंज होईल का नाही? Okay, as the induced EMF it can be changed, or the EMF induced by the generator it will be changed or it will be vary. Then the speed of DC shunt motor whose speed we want to control, so this speed it can be changed. That's the speed काय will change. Okay, so see how it can be done. बघा, see, ही motor constant speed न run होते. This motor it can be run as a constant. En of the generator it is constant, so Eg induced EMF it is directly proportional to flux of the top generator, and the flux it can be varied by using a field regulator. एका field regulator चा use करून काय करतोय आपण? Flux vary करतोय. If the flux it will be get vary, then the induced EMF it will be also varied. That is Eg it will be varied. So Eg is nothing but output voltage, it will be vary. So generator output voltage it will be vary. That means this voltage it can be applied to the top motor whose speed we want to control. So again the speed of this motor it will be vary. Motor's speed kai will vary. Now see, if this field regulator having an zero value, that means line current it is provided to that of field winding, there is no resistance. At that situation the flux is maximum. Flux का असतील maximum असतील. If the flux is maximum, the induced EMF is maximum. If the induced EMF is maximum, the speed obtained by this DC shunt motor it is maximum. If I insert the resistance in series with that fieldच्या series मध्ये जर resistance मी insert केला, what will happen? The current flowing from that field winding it will be reduces. If the current flowing from field winding it will be reduces, the flux value it will be reduces. If the flux value it will be reduces, then the Eg it will be reduces. So if the Eg it will be reduces, the supply voltage of the top motor it will be reduces. If the supply voltage of the top motor it will be reduces, then the speed of the motor it will be also reduces. That means there is a change in speed. Speed मध्ये काय will change. Now another one device it can be used here. One of the reversing switch it can be used here. याच्यामध्ये काय केलेलं आहे बघा, एक RS switch use केलेलं आहे, or we can call it as a reversing switch. Suppose initially the motor it can be running on clockwise direction. Motor जर clockwise direction ला run होते. Suppose if I connected like this, it will be connected like this. हे जे switch आहे ते या डिरेक्शनला कनेक्ट केलेलं आहे बघा. सपोज इट विल बी कनेक्टेड लाईक दिस. बघा, लाईन इट कॅन बी कनेक्टेड टू फील्ड वाइंडिंग. अगेन line it can be connected to field winding by using one of the field regulator. Suppose याचं कनेक्शन काय आहे या टाइप मध्ये. Now see, suppose at that situation your motor it will be running on clockwise direction. मोटर काय होते या कंडिशनला clockwise direction न रन होते. Now I am changing the position of that switch. Switch ची पोझिशन काय करतो मी, चेंज करतो. ओके, सपोज दिस टर्मिनल इट कॅन बी कनेक्टेड हियर. हे जे काय टर्मिनल आहे, सो दिस स्विच टर्मिनल इट कॅन बी कनेक्टेड हियर. इथं कनेक्ट केलं आणि हे टर्मिनल मी इथं कनेक्ट केलं. व्हॉट विल हॅपन इफ वी मेक द कनेक्शन रिव्हर्स? व्हॉट विल हॅपन? whether the current it will be flowing from same direction or it will change its direction. Simple question is there.
Change the direction.
Change its direction. That means suppose पहिल्या कंडिशन मध्ये जर करंट या डिरेक्शन न फ्लो होत असेल, सपोज या डिरेक्शन न, त्यावेळेस मला स्पीड क्लॉकवाइज डिरेक्शन न मिळतंय. नाउ I am using reversing switch. I will change the connection reverse, or I will reverses it. When I will do the reverse connection, current it will be flowing in the opposite direction of that of previous one. Previous one च्या opposite direction न current flowing. That means current it will be flowing in the upward direction. Like this, the current it will be flowing in the upward direction. If the current flowing from the field winding, if it is change its direction, the output voltage obtained it will also change its direction, or the flux produced by that it will change its direction. If the flux produced by that it will be change its direction, that means the current produced by the generator it will also change its direction. That's direction काय will change will. That means opposite supply voltage it can be applied to that of motor. Motor ला काय will opposite supply voltage apply केलं जाईल. Due to that opposition it will be occur, the motor it will be running in anti-clockwise direction. That means बघा, suppose 1500 RPM ला initially motor run होते clockwise direction न. If I use the reversing switch, at that situation the current it will be changes its direction. Due to that the motor speed it will be also changes its direction. That means motor it will be running on anti-clockwise direction. म्हणजे 1500 RPM ला रन होणारी clockwise direction न मोटर हळूहळू 0 revolution per minute ला येईल, and once it will be get 0 revolution per minute, it will be running in the opposite direction as that of rated value. So it will be running on anti-clockwise direction up to 1500 revolution per minute. 1500 revolution per minute ला काय करेल ते opposite direction न run होत. Okay, it will be runs to the top opposite direction. It will be runs to the top opposite direction when we apply the reversing switch. त्यावेळेस reversing switch apply करतोय त्यावेळेस ती opposite direction न पण काय होईल run होईल. Okay, so see, we are able to achieve the speed from 0 to maximum value in one direction. Also we are able to achieve the speed from 0 to maximum in other direction. Okay, so final conclusion काय आलं याचं, आपण स्पीड याचं कंट्रोल करू शकतोय from 0 to maximum in one direction. Also we are able to control the speed from 0 to maximum in anti-clockwise direction. Okay, so see, म्हणजे आपण क्लॉकवाइज ला पण रन करू शकतोय as well as anti clockwise ला पण रन करू शकतोय from 0 to maximum, from 0 to maximum. So this is the conclusion. That means this speed control technique, that is Ward-Leonard speed control of DC shunt motor. This technique it can be used where the speed requirement having an wide range. Wide range मध्ये जर speed requirement असेल, so for a wide range of speed requirement, we are able to use these types of technique like speed control technique by using a Ward-Leonard system. Okay, Ward-Leonard system चा यूज करून आपण काय करू शकतोय, स्पीड कंट्रोल करू शकतोय इन केस ऑफ बोथ डिरेक्शन. लक्षात आलं? हॅलो,
Yes, sir.
see, here we are able to control the speed of DC shunt motor in the wide range in both direction. दोन्ही direction ला आपण wide range मध्ये काय करू शकतोय, कंट्रोल करू शकतोय. So see, if our speed control requirement it is from 0 to maximum in clockwise direction for some time, and it is for 0 to maximum in anti-clockwise direction for some time. Sometimes साठी माझी requirement आहे from 0 to maximum in clockwise direction and from 0 to maximum in anti-clockwise direction. At that situation, I am able to use this technique. Okay, so the speed, it may be obtained from 0 to maximum in one direction and from 0 to maximum in other direction. So to achieve that speed or to achieve that speed control, we required one MG set, that is motor generator set, in addition with that motor whose speed we want to control. ज्या मशीनचं स्पीड मला कंट्रोल करायचंय त्या मोटरच्या ऍडिशन मध्ये मला एक एक्स्ट्रा MG सेट काय आहे रिक्वायर्ड. So instead of using a DC shunt motor, we are able to use AC motor also for providing mechanical energy to that of generator. जे जनरेटर यूज करतोय त्या जनरेटरला मेकॅनिकल एनर्जी प्रोव्हाइड करण्यासाठी आपण AC इंडक्शन मोटर पण यूज करू शकतो. ओके, सो सी दिस इज द MG सेट, this one is the MG set and this is one motor whose speed we want to control. ज्या मोटरचा आपल्याला स्पीड कंट्रोल करायचंय, this one is the motor whose speed we want to control. Okay, I think all of you understood this point, that is Ward-Leonard system of speed control. If our speed control requirement, it is maximum, having a wide range speed control requirement. Okay, wide range speed control requirement, at that situation we are using this technique like Ward-Leonard speed control technique. म्हणजे आपल्याला झिरो काही वेळासाठी मी ती मशीन 0 रिव्होल्यूशनला पण रन करू शकतो. दॅट मीन्स समवॉट 0-10 रिव्होल्यूशन पर मिनिट. तीच मशीन मी 1500 रिव्होल्यूशन पर मिनिटला रन करू शकतो एका क्लॉकवाईज डिरेक्शन. तीच परत अँटी क्लॉकवाईज डिरेक्शन मी 1500 RPM ला रन करू शकतो, 750 ला करू शकतो, 250 ला करू शकतो, लाईक दॅट अगेन 0 ला करू शकतो. राईट, सो दिस इज द if our requirement, it is nothing but wide range requirement, our speed control requirement, it is nothing but wide range. At that situation we are using such technique like Ward-Leonard system. Ward-Leonard system speed control technique आपण त्या कंडिशनला काय करतो, यूज करतो. ओके, getting
Yes, sir.
It is depends upon our application or as per my requirement. Suppose for example in sugar industry there are one motor is there where the juice, it will become from molasses to we want to make the sugar. म्हणजे ऊसाचा जो काय रस आहे त्या रसापासून ज्यावेळेस मी साखर बनवतोय, म्हणजे मोलॅसिस पासून साखर बनवतोय, at that situation one motor is used there. Sometimes this motor, it can be running on 1500 revolution per minute. काही वेळासाठी ती मोटर 1500 रिव्होल्यूशन पर मिनिट ला रन होते. and for sometimes it is running on 250 revolution per minute. Okay, बघा, I think this is a 3 minutes operation, 3 मिनिटाचं ऑपरेशन आहे. Instead of using, now recently there are multiple speed control technique it can be used, like speed control, it can be used by using a VFD drive, that is variable frequency drive. Suppose 1750 kg VFD drive is there, एक 1750 kg चा VFD drive आहे. This drive, it will be run the machine for 1500 revolution per minute for some time. Again it will be run 250 revolution per minute for some time, and this operation, it can be completed within 3 minutes. 3 मिनिटांमध्ये ऑपरेशन होतं. बघा, if the molasses or juice comes into that tray, एक मोटर असते DC शंट मोटर, त्याच्यावरती एक ट्रे असतो, having a big size tray. At that situation the molasses or juice, it can be comes on that tray, it is near about 750 kg, 1750 kg चा ज्यूस काय होतो त्या ट्रे मध्ये येतो. Now this tray or motor, it can be continuous running. मोटर काय असते ती continuous running मध्ये असते. When the tray it is empty, at that situation the motor, it will be running on maximum speed like 1500 revolution per minute. त्यावेळेस ती मोटर 1500 revolution per minute ला रन होतं. Now suddenly load on that tray, whether it is increasing or decreasing, अचानक त्याच्यावरचा लोड काय होतोय, इन्क्रीज होतोय का डिक्रीज होतोय? बघा एक मोटर आहे. On that machine there is one of the tray is there. So see, initially this tray it is empty. Initially this tray it can be empty. At that situation this machine it can be run on 1500 revolution per minute. 1500 revolution per minute ला motor run होते. Now see the molasses or juice it will be comes in that tray. या ट्रे मध्ये molasses किंवा juice काय झालेलं आहे आलेलं आहे. Suppose near about 1750 kg juice is there. Whether the load it will be increases or decreases. मोटरवरचा लोड इन्क्रीज झाला का डिक्रीज झाला? इन्क्रीजेस, बट इट इज सडनली इन्क्रीजेस. म्हणजे फॉर 1 minute और इट मे बी फॉर 30 सेकंड साठी लोड काय झाला अचानक त्याचा 1750 kg झाला. इफ द लोड इन्क्रीजेस दॅट मीन्स at the mechanical output side there is a load on the machine, it will be increases. At that situation the suddenly speed of the motor it will be drop. मोटरचं स्पीड काय होईल? सडनली ड्रॉप होईल. So speed it will be obtained near about 250 revolution per minute. At that situation from changing speed 1500 revolution per minute to 250, this juice it will be dry out and it will be due to that centrifugal force the this juice it will be dry out and it will be what we can call it as it will be stick on the inner side of the tray. Okay, जो काही ट्रे आहे त्याच्या आतील बाजूला काय होईल तो ड्राय ज्यूस किंवा त्याचे आपण शुगर फॉर्मेशन म्हणतो ते आपण इट विल बी स्टिक ते इनर साइडला त्याच्या चिटकलं जाईल. राईट नो. सो दिस ऑपरेशन इट कॅन बी हॅपन from within 3 minutes if we use the VFD drive, that is variable frequency drive. If we are using a variable frequency drive, at that situation this operation it will be completed within 3 minutes. Now see, this dried sugar it can be carried out or it can be taken out. Again this tray it may be empty. परत जर ती फॉर्म झालेली शुगर आहे किंवा साखर आहे ती रिमूव्ह आउट करून घेतली म्हणजे ट्रेचा एखाद्या साइडला ओपनिंग असेल, फ्रॉम दॅट ओपनिंग इफ इट इज रिमूव्ड आउट अगेन इट विल बी एम्प्टी. अगेन दिस 250 रिव्होल्यूशन पर मिनिट इट विल बी इन्क्रीज्ड अप टू 1500 रिव्होल्यूशन पर. परत ती मोटर 1500 RPM ला काय होते रन होते. ओके, ग्रॅज्युअली इन्क्रीजिंग द स्पीड. सो लाईक दॅट some VFD drive it can be recently used for controlling the speed of DC shunt motor or it may be speed of the motor. So this is related to Ward-Leonard system. Some of the advantages it can be given here. So advantages of DC motor if we use the Ward-Leonard system. See, first one advantages is that the speed of the motor it can be adjusted through a wide range without inserting any one of the resistance. So if we are not inserting the resistance, that means losses are minimum and getting an maximum efficiency. आपण त्याच्यामध्ये रेजिस्टन्स इन्सर्ट करतोय का कुठे त्या मोटर मध्ये? हा, so we are not inserting resistance. So if we are not inserting resistance, that means there is a minimum losses, and if the minimum losses is there, the efficiency obtained by this machine by using a Ward-Leonard system it is maximum. Second one is nothing but the motor can be brought to a standstill quickly. म्हणजे 1500 RPM ला रन होणारी मोटर आपण स्टँडस्टिल कंडिशनला म्हणजे झिरो पोझिशनला आणू शकतो क्विकली, सिम्पली बाय रॅपिडली रिड्युसिंग द व्होल्टेज. कशी आणतोय आपण? फक्त ते व्होल्टेज चेंज करतोय सिम्पली बाय रॅपिडली रिड्युसिंग द व्हॅल्यू ऑफ व्होल्टेज सो ऑफ द जनरेटर. When the generator voltage is reduced below the back EMF of the motor, this back EMF sends current through the generator armature. बघा, जी मोटर आहे त्या मोटरच्या बॅक EMF पेक्षा जर व्होल्टेज रिड्यूस झालं जनरेटरचं, म्हणजे सप्लाय व्होल्टेज इज लेस दॅन EB, at that situation due to more back EMF it will produce some current and this current it will be fed to that of supply line. सप्लाय लाईनला तो करंट काय केला जातो? फेड केला जातो. दॅट मीन्स इस्टॅब्लिशिंग अ डायनॅमिक ब्रेकिंग. while this takes place the generator G operates as a motor ड्रायव्हिंग मोटर ए विच रिटर्न्स पॉवर टू द लाईन. ते काय करेल, लाईन मध्ये परत पॉवर जनरेट केली फेड करेल. ओके, सो दिस इज अनदर वन advantages. And the last one advantages is that this method is used for the speed control of large motor when a DC supply is not available. Okay, when a DC supply is not available, this method it can be used to the speed control of large machine or big size ज्या machine असतात त्याच्या speed control साठी यूज करतोय. when DC supply it can be not available. ज्यावेळी DC supply available नाहीये, at that situation use करू शकतो. Now one of the disadvantages is that the disadvantages of odd-Leonard system is that the special motor generator set is required. That is special one of the MG set it can be required. एक मोटर जनरेटर सेट रिक्वायर्ड आहे फॉर ईच मोटर. म्हणजे प्रत्येक मोटरला, ज्या मोटरचं मला स्पीड कंट्रोल करायचं आहे त्या मोटरसाठी एक सेपरेट MG सेट रिक्वायर्ड आहे. सो सी, ड्यू टू दॅट MG सेट द लॉसेस इन द सेट आर हाय. जो काय सेट आहे MG सेट त्याचे लॉसेस हाय असतील. सो इफ द मोटर इज ऑपरेटिंग अंडर लाईट लोड कंडिशन फॉर अ लॉंग पिरियड. जर मोटर कमी लोडला ऑपरेट होत असेल फॉर अ मॅक्झिमम टाइम और इट मे बी फॉर अ लॉंग पिरियड, देन देर इज अ लॉसेस इट विल बी ऑकर इन दॅट ऑफ MG सेट. MG सेट मध्ये, मोटर जनरेटर सेट मध्ये काय होते, लॉसेस ऑकर होते. अँड ड्यू टू दिस set required for individual machine, the cost requirement is also more. त्याची जी काही कॉस्ट रिक्वायरमेंट असेल, इनिशियल कॉस्ट रिक्वायरमेंट इट इज more. So these are the advantages and disadvantages of Ward-Leonard system. Okay, getting all of you?
Yes.
Okay, so in this way we will conclude this today's lecture. Remaining point, that is speed control of DC series motor, we will discuss in the next lecture. So we will conclude and we will stop here. Thank you.